Okay, now before we start the homework, I just want to show you something. If I was to have a circle, remember, if a mirror is curved, it's going to be circular. So if I'm going to have a concave mirror, which is what we're going to do today, I always have to have a frame of reference. You see my little black dot? I have my principal axis here, and then this black dot represents where the light hits the mirror. Now remember, when it hits, it's going to bounce off. So when we draw ray diagrams, we're just going to draw the mirror as like a vertical line because it just makes it easier for drawing ray diagrams. Okay? So remember, the center of curvature would be like the center of the circle, and then the focal point is going to be half of that. So when you do ray diagrams, you actually have to do them to scale. You can't just draw them freehand, because if you don't draw your focal point in the middle of the center of curvature, you see how it's not going to come out correctly? Okay? Again, let's go over our sign convention. So up is positive, down is negative. All right? To the right is going to be negative because this is the surface it's being reflected off of. So this is going to be positive, which is real, and this way is going to be negative, which is virtual. Okay? So this is our frame of reference we're going to use for concave mirrors, which is what we're doing today. Okay? So let's look at problem number 2. Now first I'm going to do it graphically, and then I'm going to do it mathematically, because mathematically is so easy, but if we want to rearrange the equation to solve for the unknown from the known. So we're going to do number 2. So number 2 says, a concave shaving mirror has a focal length of 33 centimeters. So I'm going to do like I always do. I'm going to write my given. The focal length is 33 centimeters. And I don't have to convert this to meters, because if everything's in centimeters, my final answer will just be in centimeters. So you don't have to worry about that. The only time you have to convert is if the units are different and you want to make them all the same. Then it tells me calculate the image position of a cologne bottle. So I want to see, where is the image? So if I want to find the position of the image, that's going to be DI. And then it also says in front of a mirror at a distance of 93 centimeters. So the distance of the object, the cologne bottle, is 93 centimeters. Okay? So then it says, is the image real or virtual? So that means I really want to know, is that the only thing it asks? Is it inverted or upright? So the magnification, M, is going to tell me if it's inverted or upright. If it's real or virtual, if DI is positive or negative, that's going to tell me if it's real or virtual. Okay. So first let me do it mathematically, and then I'll do it graphically. So first of all, mathematically, I'm going to use my one equation. 1 over F is equal to 1 over DI plus 1 over DO. Now, in all these situations, I'm either solving for F, DI, or DO. And I know how you just love plugging numbers in your calculator. When you plug numbers in your calculator, that's how you make a mistake, because you forget to press a button, and then you get the answer wrong. If we rearrange the equation to solve for the unknown in terms of the known, we're less likely to make a mistake. So in this case, I'm solving for DI. So I can do basic algebra. So what I'm going to do is, if I want to solve for an unknown, I'm going to leave it where it is, and I'm going to move everything else. So the first step I'm going to do is say 1 over F minus 1 over DO is equal to 1 over DI. So all I did was subtract this from the other side. Remember, memorization is not your friend. There's only so much your mind can memorize. If you just do basic algebra, you can rearrange any equation algebraically, and it's simple. Now, I cannot subtract these because they do not have a common denominator. So what the only common denominator I would get would be multiplying these two together, right? So now I'll do a common denominator I'll call DOF. And remember, this is a subscript. So in order to get this to be DO times F, what I'd have to do is I'd have to multiply top and bottom by DO, because DO over DO is 1. So this becomes DO divided by DOF minus, so to get this to be DO times F, I would have to multiply top and bottom by F, because F over F is 1. So this is going to be F over DOF is equal to 1 over DI. So now I will do my subtraction because I have a common denominator. So DO minus F over DOF is equal to 1 over DI. Now what we learned before is whenever I have fractions, the best way to simplify, your best friend, is cross multiply. So that means this times this is equal to this times that. So DO minus F times DI is equal to DOF. Since I want to solve for DI, I'll subtract by this, so I end up with DI is equal to DOF divided by DO minus F. Basic algebra. So whenever you took Algebra 1, you learned how to do this. Because what if this equation said 1 over x is equal to 1 over y plus 1 over z? Would you be able to do that? We did that the first week of school. Because on the worksheet on basic algebra, I made up a problem like that because I knew that it's just like this. Okay? We just have different variables. We have f, we have di, and we have do. So now I'm going to substitute in my values. So DO is equal to 93 times 33 divided by 93 minus 33. So this comes out to be 51 centimeters. So then I want to find my magnification. So magnification is equal to negative DI over DO. So it's negative 51 divided by 93. So my units cancel because magnification has no unit. And this comes out to be negative 0.55. So first of all, this negative sign means that it's inverted or upside down. So one of the questions was it inverted or upright? So this means that it's inverted, which means upside down. And the last thing they wanted to ask me was, they said, was it real or virtual? So because DI is positive, positive means that it's real. So that's how I answer all those questions. All right, now we're going to do the same problem, but we're going to do it graphically using a ray diagram. So doing it graphically using a ray diagram, I have to draw a picture. So what I'm going to do first is I am going to draw with a ruler. I'm just going to draw a straight horizontal line like this. Then I'm going to do a vertical line to represent my mirror, because those are going to be my frame of references. So this is my principal axis, and then this is my mirror. So remember, for the principal axis, this is positive, this is negative, and for the mirror, for concave, this is positive and this is negative. So those are my frame of references. So now it says that the object is, so first I have to establish my center of curvature. Now they tell me the focal point is 33. So I'm going to just take my ruler and I'm just going to do this, and I'll say, okay, this is, I did 3.3. So this is going to be, let's say that, let me divide that by half. So, or let me use a different scale. It really doesn't matter, but you have to do it to some kind of scale. So I'm going to say, okay, this is going to be my focal point, F. And then, because on this I drew it, I just didn't want to go off the paper. So whatever my focal point is, remember the center of curvature is twice. So then I'm going to measure. So here's my center of curvature. And now it tells me that my object is placed at 93. So that's almost 3 times what the focal point is. So now I'm going to draw that. So here is where my object is going to be placed. So here's my object, which I'm going to draw by an arrow. Okay. So how do I start? So there's 3 rays that you draw, but you're going to see you only need 2. So ray number 1, and you don't have to draw 3, you only have to draw 2. So, and where they intersect shows your image. So ray number 1, you're going to go parallel. You're going to hit the mirror, and then you're going to go through F. So let's do that. You go to the top of the image. I'm going to go parallel till I hit the mirror. Once I hit the mirror, then I'm going to go through F. So this is where I hit it, and now I go through F. So this is ray number 1. Ray number 2, I'm going to go through F. I hit the mirror. Remember, when it hits the mirror, it reflects or bounces off. And then I'm going to go parallel. So those are just the opposite of one another. Okay? So now I'm going to go through F. I'm going to hit the mirror, and then I'm going to go parallel. So that's ray number 2. Should have done them in different colors. Now, where those lines intersect, that's where my image is formed. So see right here? There's my image. And that's it. Now, graphically, is this larger or smaller or the same size as the object? It's smaller. Is it upright or inverted? Inverted. Is it real or virtual? It's real. So by doing it graphically, I also see that I can get the same answer that I did mathematically. And then the third rule is, and this one's the easiest, so you might want to do like 1 and 3. Ray 3 is you just go back and forth through C. So what that means is you just go from the top of your image through, you go back and forth through the center of curvature. And do you see how it intersects exactly at that same point again? So I did a pretty good job of doing it graphically. So you see how that also intersects at that same point. So you don't need to do all 3 rays. You can just do 2 of them. So you can do 1 and 2, you can do 1 and 3, or you could do 2 and 3, and you're going to get it. So now we see, here's my object. This is my image. So I see my image is inverted. It's smaller than my object, and it's real because it's on this side of the mirror. So this is how you do it graphically, and then that's how we do it mathematically. Practice makes perfect. This is the first one that you did. You watched me do it. Then you're going to practice and do some more yourself. And that's it.